All right, so first speaker after lunch, Steve Lyness from Appro.
Thank you. Always good to be the speaker right after lunch. Okay, so I was asked to give a presentation to talk about how a company is able to do well, like Appro has done recently, in a global marketplace, right? Appro does business not only in the continental United States, but also a lot of business over in Asia Pacific, some business as well over in Europe, and now on into Australia. So when we look at the key drivers and how does a smaller company make inroads, right? A lot of it has to do with a couple of key points, right? Deep technical pre-sales knowledge, best of breed engineering teams, focus on high performance computing, best of breed technology partners, and delivering on promises, because as we all know, the HPC industry is a very small community, and everything you do ends up under a microscope, not only for the customer that you're working with, but also for the industry as a whole. But when you look at the overall list, it really comes down to the people, right? So the first thing is having people who can have intelligent discussions with the customer, right? Being able to really understand what the drivers are, understand what their concerns are, where their keys are, right? So as in the example that I'm going to use, which is based on Tsukuba University in Japan, right? The highest concerns were fixed budget, high availability, getting the latest processors. The system that they wanted to take advantage of accelerators, and they had a very specific 2-to-1 ratio that they wanted for GPU to CPU within the node. High bandwidth was very critical to them because they really needed to be able to feed those GPUs. Right? High bandwidth, low latency networking, high I/O bandwidth to storage, and then finally easy to manage, because as we all know, the number of resources that people have to operate the systems and manage the systems continues to get more and more challenging, right? There seems to be more capital dollars than there are dollars to go and hire people. So the ability to manage a system very easily. So when we talked about fixed budget, then we had to work with the customer to determine what that balance was, right? Between all of the different pieces that were important to them, right? Whether it was performance, whether it was flops or bandwidth, capacity, right? The number of nodes, the amount of storage, the high availability features, right? Because all of these things come with cost. And then the ease of management and supportability, right? So all of these things are easily fixed as long as you have a lot of dollars to throw at them, but nobody has an unlimited budget. And then finally, we talked about high availability, right? As the systems continue to grow, the jobs continue to get more complex, without the ability to do checkpointing, right? Even with checkpointing, you want to make sure that your job is going to run through to completion. So, when you look at the nodes, fans, power supplies, the interprocess communication networks like InfiniBand, and then the operations networks like Ethernet. So we looked at the node design, right? And we started this about a year before the system was actually built. Right? We looked at designing a node with the latest generation of processors, the needs for flops and I/O capacity, right? Being able to balance, have a really high I/O bandwidth to be able to talk to all the GPUs that they wanted. And a high memory capacity, because the systems that they had, the applications that they ran, really required a very high capacity in memory. So we worked with Intel ePSD very early on and designed a motherboard, right, which, if you've seen it, is now called Washington Pass. Right? It's a dual Sandy Bridge node, right? So we selected Sandy Bridge because of the ability to have the high I/O bandwidth, right? Because we could bring 4 PCI Express Gen 3x16 accelerators out, and then 1 additional by 8 for the I/O expansion slot. And it also, this system, this motherboard was designed to have 2 DIMMs per channel, right? Which gave us the memory capacity without having to go to really high capacity and more expensive DIMMs, right? So now we could do, instead of 8 DIMMs like on the Jefferson Pass motherboard, we could go to 16 with Washington Pass. And then we went with a 2U form factor for fit and function and airflow. So if you look at the Washington Pass motherboard, this is an overall look at the architecture, right? 2 Intel Sandy Bridge chips. Off of each chip, we brought out 2 by 16 connections, right, that went out to the individual GPUs, right? And then a by 8 that went to a Mellanox HCA, right? We could do Mellanox ConnectX-3 down on the motherboard, but we ended up going with an HCA so that we could bring a dual port so that we could have the redundancy. And then dual gigabit Ethernet, with connectivity up to the Intel chip with connectivity over to the BMC so that we could bring BMC information out through the GigE ports and be able to have redundancy in the Ethernet networking as well. Right. The next challenge, as I mentioned, was high availability, right? So could you build in redundant power supplies, hot swap fan trays, hot swap disk drives, and redundant networking? Right, so what we did was we took that whole node with the Washington Pass motherboard and a 2U form factor, and we built it into a blade. Right, so Appro has our flagship product line, which is called GreenBlade. Right, GreenBlade has these hot swap large fan trays, so they're very power efficient versus the little fan trays, but they're also hot swappable. Hot swappable power supplies, high efficiency 95% plus. So, and then the ISCB module. This module talks to an I2C network across the midplane and can actually control, monitor, and do console redirection. So what we wanted to do was be able to use this node into the same type of chassis. So we built this an 8104, so this is the next generation, the 8204. We built the 8104 originally for similar 2U type blades that would have additional I/O and storage capacity. So we built one for this new node. Right, so now we could plug 4 of these nodes into here, share the power supplies, right, these hot swap power supplies, the hot swap fan trays on the other side, and then the redundant ISCB modules, so that we had not only the Ethernet connectivity in, but we also had the ISCB connectivity through the I2C network to be able to get to the nodes and do things like power on, power off, reset, console redirection, BIOS upgrades, all of those things through that port as well, right? So we weren't dependent on the IPMI interface. Then the next one was to do redundant networks. Right, so the GigE, as I mentioned, had redundant connectivity on the motherboard into the IPMI and then the redundant ISCB modules. Right, so now if you look at the node, we can bring in GigE, we can bring dual rail QDR InfiniBand out. Right, even with the by 8, we can do pretty much full bandwidth QDR, right, using the Gen 3 interface. So now we've got dual rail InfiniBand, we've got dual rail Ethernet, we've got hot swap hard drives, hot swap power supplies, hot swap fan trays in a very economical way for the customer. So the point is being able to, the reason why we did well with them is we worked with them very early, right? A lot of it was done by conference call, right? We don't have to travel over to Japan anymore. We can do go-to meetings. But listening to the customer, understanding, having the technical expertise in-house to be able to understand what their needs are, and then having on the back end the engineers who can go in and redesign product, right? Whether it's working with a partner like Intel, right? Doing Intel ePSD, working with our vendors, right? to come up with unique ways of meeting the customer's requirements and creating that balance, right? So that they're getting, I mean, we built this 800 teraflop system for a lot less than people thought it could be built for, with all of the high availability features that were built into it, right? But that comes a lot from the ability to focus on what's important for the customer, right? But then that's what a small company like Appro, and we're not the only one, right, but we're pretty good at what we do. We focus on high performance computing, right? Which you can see from this. The Appro HPC software stack, right? Appro not only builds hardware, right, but we listened to our customers and we created a full software stack that starts all the way at the bottom with Red Hat or its derivatives like CentOS and SUSE. Right? So we work with it, and this keeps expanding. Right? But right now we do ACE, which is the Appro Cluster Engine software that does provisioning and things like that, right? Being able to monitor the systems. So it's having the focus, being able to build the systems, being able to manage them and monitor them, that has gotten Appro the visibility not only within the United States, but now we even have customers from Europe, from Switzerland, from Norway, from Australia who contact us because of the job that we've done for others, not only in building these specialized products, but also in delivering them and supporting them. Right? Again, it goes back to the people and the ability to have the kind of reputation that you need, right? So it's easier today than it used to be able to go out and generate interest on a global basis, right? Because of being able to do go-to meetings or net meetings or all of the different ways that you can have communications with your customers. You can have a face-to-face and still be 5,000 miles away, right? But then it still comes down to execution, right? And being able to drive that, because the other side, the flip side of that coin in this global marketplace is everybody knows everything about everyone, right? As soon as you fall down and don't do well, everybody knows about it, right? Whether it's something you don't deliver, it takes twice as long as you said it was going to, it doesn't perform. Everybody knows all the stories of, you know, the companies that didn't do well, right? And part of the reason was once they failed, everybody knew about it, and people were more reluctant to give them additional opportunities to fail with them, right? Because there's a lot of dollars on the line. Excuse me. Best of breed partners, right? And this really is very important. Not only having partners that are recognized globally, but ones that can help make it so that you can continue your own reputation. Appro has a very selected group of partners, right? For instance, we do a lot of Ethernet networking, right, to do management. And we partner with Brocade. Brocade has done a great job for us on a number of different fronts. One of them is training. Right? We get full training on pre-sales, right, so that we understand what these products are going to do, so we're not selling something that isn't going to do what we say it's going to do. We get training on installation. Right? We have a great installation team, but if they don't understand how to make the product work, it'll take more time in front of the customer than we had planned on, and certainly as we would want to, right? And then also on the support side, right? So we have a very limited number of best-of-breed customers, and really a lot of it has to do with not only how they perform, right, what their features are, how flexible their products are, but also the training programs, right? Because it's not about just throwing something out there. I mean, you can be a VAR and there's not a lot of value in a lot of VARs, right? They just throw equipment out, they put it in boxes, they send it, and they say, well, it should work. Appro doesn't do that, and that's why, right? But one of the reasons why we don't have to is because we have very good training from our partners. That's it. Any questions? All right. Thank you very much.